Hello everyone, I'm Swapnil Rawat. In my experiments on computer graphics and the series today, I'm going to discuss the topic of drawing curvy objects. For example, today the main aim of my experiment is to draw this shape of this guava. You can see it has a number of curvy outlines. And that they just change every now and then. So I'm going to try and draw this. So what I did first was just I drew a rough sketch of this guava like this, so as to get to know how many curves I actually have to deal with. So you can see one curve is on the top, the sides are curved, and the bottom is a separate curve. So that's what our aim is, that's what we want to display on our screen today. So this implementation is to be done using the Casteljau algorithm, and the curves drawn using that algorithm are came to known as Bezier curves. So the idea is like we will have a number of endpoints representing a number of lines. For example, this figure actually consists of 5 lines. What we do is here we use a parameter. It can be u or it can be t. So when we put a value of t and for example, if it's a line is given and the value of t varies from 0 to 1, so if it is 1, then we actually mean to refer to the whole line segment AB. But if it is zero point 0.5, then we mean to refer to the only half part of the line starting from A to some midpoint which can be C. So accordingly, when we change our value of t, we get a portion of line. We get only a portion of line. And here you can see in this given figure they have named the parameter as u and they have taken the value as zero point 0.4. So that will mean that proportionately in the ratio of 4 is to 10 or 2 is to 5, we are taking this part of each and every line. So we have 5 lines, so we will take the portion corresponding to the u value equals to zero point 0.4. So after taking those points which actually corresponds to the zero point 0.4 function, zero point 0.4 partition of the given lines, and then we will have 5 points which will lie in somewhere between these 5 lines. And when we join these 5 points, we actually get 4 lines. So but then we repeat the process with the same value of u, and eventually you can see the number of points get decreased and the number of sides get decreased as well. Finally we will reach a single line, and when we again take zero point 0.4 portion of that line, we will get a final point. So you can see for a single value of u, when we increment it by small intervals, we will get a number of points. So when we plot all those points, we will get our required curve. If you just take 4 lines, then we will get a curve somewhere which will not be so round, it will be a bit like an arc. So if we use 4 lines, we'll get an arc. So I'm discussing that because we are actually going to implement for the Casteljau algorithm to draw a Bezier curve using 4 lines only. 4 lines. Oh, actually, it will be using only 3 lines. We will be using 4 endpoints, which actually give us 3 lines. So we will use the algorithm for 3 different lines. How will we get that coordinate of each and every point? What we have to do first, we have to take product of these 3 matrices T, M, and P. So T is defined as T cube, comma T square, comma T, comma 1, which is a vector. M is this matrix. This is a multiplication factor which we have to use, and P is just our endpoints of the given endpoints, which actually consist for those 3 lines. So now what we have to do, we can actually take a look at the coding part. So you can see I have just defined my 4 endpoints which will give me the required curve, and then after that I have given the matrix M in this format. I have taken it to be a float nature because further we can have decimal calculations considering that into fact. And chord is the final x and y coordinates which will be getting for different values of t. So to make the simplification in multiplication, I've just defined a function to multiply the three matrices. You can see first I have multiplied the T matrix, which is this one, with the M matrix in the this portion of the code. So yeah, I multiplied the T matrix with the M matrix. I have defined this for loop in such a manner, and after that multiplied that result with the matrix which contains our given points. So this is the matrix which contains our given points. At the end of the product we will get our coordinates. So now you can also see that I am doing that for four different points, and when I implement it here, what I am doing is I'm changing the value of t as well. So t is incremented at the end of this while loop by a very small value. So this will actually help us to get all the points which are to be drawn for our required curve. This first multiply function I've used using the first set of points. These set of points actually, like you can see, for each set of points we are having four different points which will give four different sets of three lines. So each and every three lines will actually give us a curve. So for the first set will give us this top part, the second set of points will give us this left side, another one will give us right, and for the bottom we have this final set of points, points 4. This array actually stores the endpoints of the three lines which will give us that bottom part. So, and then we will just use a multiply function, and whatever coordinates we get at every value of t, we will just plot it using the put pixel function. You can see the output which we get. I'm not drawing the top, but my basic idea was to just draw the curvy part. So you can see it's pretty much identical to what we were aiming. So I guess that's pretty much all. Thanks for watching the video.